use properties of trapezoids. This is what we're going to work on 6.5. A trapezoid is a quadrilateral with exactly one pair of parallel sides. There's only one pair of parallel sides with the trapezoid. There are parts of a trapezoid. There's the bases, the legs, and the base angles. So we're going to kind of have to identify what those are. If I were to draw a picture up here. Nice big trapezoid here. Okay? The bases, the parallel sides, are the bases. So if you have little tiny arrows on here, obviously these are the parallel sides. So that's a base, and that's a base. Could you have a trapezoid like this? Could you have a trapezoid like that? Yeah? The parallel sides are the bases. Okay, these are still the bases. It's just twisted. Turned. All right, so then the non-parallel sides are called the legs. Non-parallel sides are called the legs. Let's see if I can get this brighter. It's awfully dark. It's a little better. Okay, so this is a leg, and this is a leg. All right, and the last thing that we have to define are the base angles. There's two pairs of base angles. There's this pair. Those are called base angles. They're not always going to be congruent. And I'll tell you when they are here in a second. And this is also a pair of base angles here. So, all right, there's the names of certain parts. And then there's an isosceles trapezoid. What do you think an isosceles trapezoid is? What's an isosceles triangle? What, Julia? Two of the sides are the same, exactly. Same thing with the trapezoid. If the legs are congruent, it's an isosceles trapezoid. A trapezoid with congruent legs. Oops, congruent legs. So if I were to draw something like this, that tells me that that's an isosceles trapezoid. Are all trapezoids isosceles trapezoids? Heck no. What if you had one like that? Is that an isosceles trapezoid? No, and it's a common mistake students want to make, saying that all of them are. So not all traps, I'm going to abbreviate, not all trapezoids are isosceles. This is not an isosceles trapezoid. Okay? All right, this is something new you may not know. You may have learned it already, I'm not sure. But the mid-segment of a trapezoid is a segment that connects the midpoints of the legs. So if I have a trapezoid here, exactly these points right here are the midpoints. A midpoint is exactly in half, right? Midpoint, okay? If you draw a line connecting that, that's called the mid-segment. Kind of makes sense, mid-segment. All right, so there's a formula to figure out how long that is. Okay, so this is it right here. The length of the midpoint is equal to 1/2 B1 plus B2. The length of the midpoint is 1/2. What do you think B1 and B2 stand for? The two different bases. Yeah. This is actually part of the area formula of a trapezoid. All right, so this says warm-up. It was intended as a warm-up, but I'm just going to have you guys do it as a refresher. So here it says find the coordinates of the midpoint between these 2 points. It's not using this formula. It's not saying find the length of the mid-segment. It's not saying that. It says find the coordinates of the midpoint, and this is review from last semester. Does anybody remember the midpoint formula? Joshua, do you remember it? That's the slope formula. So it is between 2 points, but that's a slope. Yes.
Y1 minus y2 divided by 2 minus x1 minus x1 or x2 divided by 2.
You're close. Instead of minus, it's what?
Plus.
It's plus. So what you do is you add the 2 x's and divide them by 2. Add the 2 y's and divide them by 2. Now remember, this is a point. So it's an ordered pair. That's why you write it like an ordered pair. Okay, your answer is going to be an x and a y. Your answer is going to be an x and a y. So I want you to take a minute and try these right here. If you're not sure, label this your first point and this your second point, and jump in and do 1, 2, 3, and 4. Look, you get to practice some algebra. Yeehaw. Practice that for a little bit. You're going to need these skills for this lesson. But you got to attach 6.4 homework if you have it. All 4. Practice all 4 real quick. Just 6.4 if you have it. So, the last 2 theorems that were on your sheet. And if you want to fill this picture right in on your sheet, you should be putting your phone away right now. Theorem 6.12, if a trapezoid is isosceles, then each pair of base angles are congruent. So let's just draw a quick isosceles trapezoid. It means that the legs are congruent, and that means if it's isosceles, the base angles are congruent. Each pair of base angles are congruent. That doesn't mean that this is congruent to this. They don't even look like it, do they? Okay? So, 6.13, if a trapezoid has a pair of congruent base angles, then it is isosceles. It's basically just telling you, hey, if these angles are congruent, then it's an isosceles trapezoid. That's all it's saying. Okay, so let's practice some of this stuff. Is a trapezoid a quadrilateral? Is a trapezoid a quadrilateral? Yeah, because it's got 4 sides, right? What do you know about the angles of a quadrilateral?
360.
In a parallelogram they are. But in a trapezoid, but they all add up to what?
360.
360. They all add up to 360, okay? So if I remember that piece of information here, I can fill in the rest of the angle measures. Okay, so this is 62. What's this right here? 62, right? Okay, so I'm going to say angle J is equal to 62 degrees. I need angle G and angle H. Now, how would I go about doing that? I know Gavin knows already, but how would I go about doing that, do you think? The angles add up to what? Okay, I know these two, so I'm going to say 360 minus 62 minus 62 equals 236. Is that what this angle is?
No.
No, I have to do what? Divide it by 2. I know they're congruent because these are isosceles trapezoids. So if I cut it in 2, that means they're 118 degrees each. They're 118 degrees each. All right? 118, 118, 118. Okay? Okay, so here, this is an isosceles trapezoid. This tells me that this angle is congruent to this angle, which makes that 70 degrees. So I want you to figure out what A and B are. Just like we did in the last problem. A and B, sorry. I attached 6.4 to it. Did you do that?
Yep.
Okay. All right. Did you get 110?
Yeah.
Okay. Some people might have put 220. You got to remember, you got to cut it in half because it's this angle and this angle. Okay, 110. All right. Find the missing lengths. So, obviously, we're looking for the mid segment, and I gave you a little formula for that. I'm going to abbreviate mid-segment equals 1/2 B1 plus B2. Half, adding the bases together. You take half of it. So, what are my bases in this picture? 13 and 7. Just because it's sitting like this, these are the parallel sides, so those are the bases. So I'm going to rewrite what I know. 1/2, 13 plus 7. 1/2, 20. What's half of 20? 10. So equals 10. X equals 10. Okay, so this is the same thing. However, are we looking for the mid-segment? What are we looking for? One of the bases, right? So I'm going to still use this formula. Mid-segment. Okay, but I'm going to fill in what I know. Do I know how long the mid-segment is? Do I know how long the mid-segment is in this? What is it? So I'm going to write 21. Replace that word with 21. 1/2. I know one of the bases is 18. I don't know the other base. So I'm filling in what I know. And here's where that beautiful little thing comes into play. This looks like a mess to solve, but really, if I get rid of this 1/2 by doing what? Multiply by 2. That makes that go away. That equals 42. The parentheses don't mean anything anymore. And I can just write 18 plus x. Subtract 18. Anybody do that in your head? What's x equal? 24. X equals 24. Okay? So you'll have some problems like that. All right, here. This gets a little ugly. I'm going to try and draw a picture just because it kind of helps. But it says you have a square 4-foot table. So here's my 4-foot table. For a wedding cake you are making. The top layer of the cake is 1 foot. So here's the top layer. It's 1 foot. The middle layer is 2.5 feet, so it's a little wider. Okay. And then I have a third layer, and I don't know how big it is. I need to know if it's bigger than the table or smaller than the table. So if you kind of draw a picture here, what you pretty much have is a trapezoid. Can you see that? And they gave me the middle layer as 2.5 or 2.5. The top layer is 1. I need to know what this is to see if it's bigger than 4. So I need to know, I'm going to use my mid-segment formula again. Mid-segment equals 1/2 B1 plus B2. And I'm using that because they gave me the mid-segment. Obviously, I have to use it to help me solve this problem. So the mid-segment is 2.5. I know one of the bases is 1. I don't know what the other base is. I got to find out if it's more than 4 or less than 4. How do I get rid of this 1/2? Multiply by 2. Both sides by 2. This goes away. What's 2 times 2.5? 5 equals 1 plus x. X equals 4. So my bottom layer is 4. Will it fit on the table? Yes. Yes, just barely. Okay. That was a fun little story, Colin. Right? What's the difference between a trapezoid and a parallelogram? Can somebody tell me? Difference between a trapezoid and a parallelogram. Lily, what do you think? All right on. She says a parallelogram has 2 sets of parallel sides, and that is true. A trapezoid only has 1 pair of parallel sides. Can a rectangle be a trapezoid? Leah? Can a rectangle be a trapezoid? Do you think? A rectangle has 2 pairs of parallel sides, right? Okay, a trapezoid does not, so no, it cannot be. Can a square be a trapezoid? No. In a square, both pairs of sides are parallel to each other. Trapezoid, they are not. Can a rhombus be a trapezoid? No. Look, all 3 of these are parallelograms, which means their sides are opposite sides are parallel. Trapezoid is not a parallelogram. Okay? So this is a no. All right. So you got quite a bit of time. You should easily be able to get